Okay, so you're used to seeing this for quadratics, right? For parabolas. The parabola is the graph of a quadratic, and you're used to seeing it in this form with an a, b, and c. So you can factor, or you can complete the square, or you can use the quadratic formula, or et cetera, right? I'm going to show you what the vertex form, or what do they call it in here? Standard form of the equation of parabola is, and all you're doing is completing the square on this equation to get the next one, like we did on the warm-up. Okay. But there are a few things that are interesting to note about these parabolas. We can go up and down or sideways. Okay, so the first change is that we're now going to look at sideways parabolas. We have some pieces of information to consider. I'll do them in colors. Try to keep these straight. Okay, do you remember what that's called? Okay, that's the axis of symmetry. In our case, it's y equals the k value, okay? The k value comes from the vertex. So you're going to see a whole bunch of stuff based on the vertex. So the axis of symmetry is a line. It'd be like y equals 4. Straight across at 4. The focus, I'm sorry you're bored already. I know, I am too. Okay, for a sideways parabola, the focus has the same x value. Sorry, the x value plus p. Okay. P is the value of the vertex to the focus. Okay, so we're going to take the vertex and just add p units to the x value to get h plus p comma k. Sorry, the plus sign. If I was writing in pencil, I'd fix it. P is also the distance to what we call the directrix. Remember that word? Unfortunately. It's x equals h minus p. Does anybody know the neat? You know how we built ellipses with the string? Do you know how these are built? Anybody? Okay. The different color. Parabola is built by measuring any perpendicular distance to the directrix and the focus. Those have to be congruent. sky is just falling. Welcome. Okay, these, so from the focus to any point, from that point to the directrix perpendicularly, those are congruent. They're the same length. That's the neat quality about a parabola. What that does is anything, you guys all, a lot of you have satellite dishes, right? Any signal coming into this parabola, like a satellite TV signal, is going to get bounced to the focus. It's going to get bounced to the focus, any signal. That's why if there's snow on your dish, it doesn't work, because the signal gets bounced in a funny direction. Okay. You're going to knock the snow off, dish restored. Okay. The equation for a sideways parabola is, now it's a y squared because it's sideways. We graded it. Yeah. Awesome. There's the equation. Okay, so algebra abstractness aside, let's do something a little bit more numerical. Like that one. Is it sideways or up and down? Anybody else want to bet the other one?
What? Yes, I would like to.
Okay, you can't double dip.
Yes, I can.
The y squared, so it's sideways. Okay. Which way does it point? Left or open? Left or right?
Right.
Why? It's positive y squared. You're correct. Okay. So we need to get it in this form. Okay. Is the left side already there? Yeah. Okay, we already have it. So how can we make the x be just an x value instead of 8x? We need the x to be a 1x, right? How can we change this so it's a 1x? Yeah, factor an 8 out. So we factored an 8 out. Okay, what is the vertex then? Knowing that this is our h, right? So -6, and k is 0. What is p? Because it's y minus k, and there's nothing there, right? Okay, what's our p value? 4p is 8. Yeah, you can say it's 2. Right. 4 times 2 is 8. Okay, so now we're going to go through and look at our different items. What's the focus
H plus P is -6 plus 2. Yeah, and then K stays the same. Our directrix X equals H minus P, -6 minus 2. Okay. And then we have an axis of symmetry. Yeah. The axis of symmetry is y equals k. So y equals 0.
Why is that eight instead of negative?
Oh, because I didn't write it correctly. How's that? -8. Thanks for the heads up there. Now you have all the info you need to graph it. If it's never mind, alrighty then. All right, so vertex -6, 0. Focus -4, 0. Directrix X equals -8. An axis of symmetry y equals 0. And now you can sketch it.
So P, if the P value is positive and on the negative side, it just,
The p-value just tells you this distance here and here, +2 and -2. Okay, all right. Think you can handle that? I should probably show you the vertical version. Yeah, that's what I thought.
go back.
Is that what you want?
Yeah.
All right, so here's a vertical parabola. You've already worked with these quite a bit, but I want to show it to you in this other form. Okay, we have a vertex. Still HK, thankfully. Axis of symmetry. What's the equation? X equals H. The directrix is y equals k minus p. Again, p is that value, and then the focus. H, K plus P. P is the distance from the vertex to the focus and the vertex to the directrix. Okay. So we're subtracting P here and adding it here. It's just like the ellipse hyperbola. Okay. Yeah, that's H and K plus P.
About when to go to Hawaii, majoring in psychotherapy, then for physical therapy program. And about her Navy, majored in French. Oh, no. About how she wanted to work in forces. Yeah, so yeah, that one too. Please, sorry.
Pretty sure you can't change that one. Okay. Sometimes you're going to run into equations that are not in the form that you like to see. So you're going to have to do some manipulations algebraically. I haven't thrown this stuff at you for ellipses, circles, or hyperbolas. Okay, it's a y. 2x squared minus 8x plus y plus 6. I haven't thrown this at you for the other stuff. Okay, but we're going to do it here. We need, so it's x squared is a vertical or horizontal? Sideways or up and down? Yeah, you're right. It's up and down because it's x squared. And it opens up or down? Yeah, because it's positive. Okay, so the question is, can we get it to this form? And I didn't write it down for you. X minus h squared equals 4p y minus k. So looking at this, I need to pull the y and the 6 over here to the right. So I'm going to subtract them both. And then on that side, I also need the y to be positive. So I'm going to pull a -1 out of everything here. And the right side is in pretty good shape. Yeah, we might have to put it back in the other form. We'll see. Eventually, we might have to use this still, but we'll see. Okay, for this side, is it anywhere close to that? Okay, so we have to factor that somehow, right? Okay. To do that, we're gonna have to complete the square. Right, so I'm gonna get x by itself. And remember to leave the blank spots for completing the square. I know. That's why I haven't thrown it at you until today. Yep. Both. So I took a 2 out of each of these. And then I'm leaving a space so I can complete the square. Do you remember how to do that? Okay, b over 2 squared, which is what do I put here? No. Okay, your instinct should be 4, but the problem is there's a 2 out here that's multiplied by 4. So it has to be an 8, or 2 times 4. Okay. So whatever you do to the left side, here we did 4 times 2, you have to do it to the right side. So we end up with, and then factor this. And I'm going to actually put this back where it was. Are you with me? Completing the square. Huh? So we end up with that better? And we just have to manipulate it a little bit more. This needs to be a positive y. So I pull the negative out. And then this number can't be here because the equation has nothing in front of the x squared value. So we're going to move it over by division. There's our equation. A lot of work. Do you need me to go through the P and the directrix and all that? Or are you good? Like, if you took this equation could you calculate P, H, and K and grab the directrix and the axis of symmetry and stuff?
Yes.
That's 2 yeses. Okay. Are there any pressing questions? There's only one of these, I think, on the homework. Okay. Give it a shot. we'll grade it tomorrow, so. Most of them are that basic first one I showed you. If you have any questions, please say. You got about 5 minutes. Try to get a partial one done.